Before we start, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss the next deep dive into the universe. And if you have ideas for future videos, drop them in the comments, because I read them all. Imagine falling toward a black hole, the most extreme object in the universe, and crossing a boundary where the laws of physics as we know them begin to break down. What actually happens when you pass the event horizon? Do you get stretched into nothing? Do you see the entire future of the universe? Or could something even stranger occur? The event horizon is often described as the point of no return. But that phrase barely captures how bizarre this region really is. From the outside, a black hole looks deceptively simple, just a dark sphere surrounded by warped light. Yet inside, it may contain some of the deepest secrets of reality. As you approach the event horizon, gravity doesn't suddenly become stronger in a dramatic way if the black hole is large enough. In fact, if you were falling into a supermassive black hole, you might not even notice the exact moment you crossed it. There is no physical surface, no wall, no flash of light marking the boundary. The event horizon is not a place you can touch. It is a region defined by geometry, by the curvature of space-time itself. Once you cross it, every possible path forward leads deeper into the black hole. Just as every direction on Earth's surface eventually leads south once you cross the North Pole. From your perspective, as the falling observer, time continues normally. Your watch ticks, your thoughts flow, and you continue moving inward. But from the perspective of someone far away, something completely different happens. To them, you appear to slow down as you approach the event horizon, your movements becoming more and more sluggish. Your light stretched into redder and redder wavelengths until you fade from view. They never actually see you cross. In a sense, you become frozen at the edge, a ghostly imprint. This difference between perspectives is not an illusion. It is a real consequence of how gravity affects time. The stronger the gravity, the slower time flows relative to distant observers. Near the event horizon, this effect becomes extreme. If you could somehow look back at the universe while falling in, you might see the outside world speed up dramatically. Stars could evolve in moments, galaxies could collide, and vast stretches of cosmic history might unfold before your eyes in what feels like seconds. Some theoretical scenarios even suggest you could witness the far future of the universe. Although practical limits like radiation and tidal forces would likely end your journey long before that. Once inside the event horizon, escape is impossible, not because you lack energy, but because the structure of space-time itself funnels all possible futures toward the singularity. The singularity is predicted to be a point of infinite density where known physics breaks down. However, many physicists suspect that the singularity, as described by classical equations, is not the true story. Quantum gravity, a theory we do not yet fully understand, may replace the singularity with something else entirely, perhaps a region of extreme but finite density, or even a bridge to another part of spacetime. One of the most famous ideas about falling into a black hole is spaghettification, the stretching of your body due to tidal forces. Gravity pulls more strongly on your feet than on your head if you fall feet first, causing you to elongate. For smaller black holes, this effect would occur before you even reach the event horizon, tearing you apart outside. But for supermassive black holes, the tidal forces at the horizon could be mild enough that you would cross intact, only experiencing the lethal stretching later as you approach the center. This leads to a strange conclusion, that the bigger the black hole, the gentler the crossing, at least initially. Inside, light behaves in ways that challenge intuition. Normally, light travels outward freely, but within the event horizon, even light moving outward still moves inward overall, because space-time itself is flowing toward the center faster than light can travel outward. Some scientists describe this as space falling inward, like a river flowing toward a waterfall, carrying everything with it. No matter how hard you swim, you cannot escape the current once you pass a certain point. Another profound mystery concerns information. According to quantum mechanics, information about physical systems should never be destroyed. But if objects fall into a black hole and disappear into a singularity, what happens to the information they contain? This question led to decades of debate, known as the black hole information paradox. One proposed resolution involves Hawking radiation, a process by which black holes slowly lose mass and eventually evaporate over enormous timescales. If information somehow escapes through this radiation, then perhaps nothing is truly lost. Some theories suggest that the event horizon itself stores information in a two-dimensional form, like a cosmic hologram, meaning everything that falls in is encoded on its surface. This holographic principle hints that our understanding of space and reality might be fundamentally incomplete. There are also more speculative possibilities. Some models propose that crossing the event horizon could lead to another universe, or that black holes might be gateways connecting distant regions of spacetime. While these ideas remain unproven, they arise naturally from certain solutions to the equations of gravity. Whether such structures exist in reality is still unknown. For the person falling in, the journey toward the center would likely be brief. Once past the horizon, reaching the singularity could take only seconds or minutes, depending on the black hole's size. During that time, the view ahead might appear distorted beyond recognition. Light from the outside universe would concentrate into a shrinking patch behind you, while the region ahead would grow darker and more chaotic. Eventually, tidal forces would become overwhelming, compressing and stretching matter to extremes. At some point, the known laws of physics would no longer provide reliable predictions. One of the most fascinating aspects of black holes is that they challenge our concepts of reality itself. They force us to confront the limits of knowledge. We can describe what happens outside with remarkable precision, but inside remains largely speculative. Observations using gravitational waves and telescopes have confirmed that black holes exist and behave as predicted in many ways, yet the interior remains hidden behind the horizon, forever out of reach of direct observation. Some researchers think the interior might not even exist in the way we imagine. Certain interpretations of quantum gravity suggest that space-time could end at the horizon, or that the interior is encoded in complex quantum correlations rather than a physical region you could travel through. Others argue that an infalling observer would experience nothing unusual at the horizon due to the equivalence principle, meaning local physics should behave normally. This tension between different theoretical expectations is an active area of research. Before we finish, I want to know what you think. If humans could somehow survive the journey, would you choose to cross the event horizon to discover what lies inside? Or is it a mystery better left alone? Let me know your thoughts in the comments because I genuinely enjoy reading your perspectives and theories. Black holes remind us that the universe is not only vast, but deeply strange, filled with phenomena that stretch our understanding to its limits. They are not just cosmic vacuum cleaners, but laboratories for testing the most fundamental ideas about space, time, and information. Perhaps one day we will have a theory of quantum gravity that reveals exactly what happens beyond the horizon. Until then, the question remains one of the greatest mysteries in science. If you enjoyed this exploration into the unknown, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you never miss another journey into the cosmos. And I'll see you in the next one.